I'm Lowena. I'm a first year student at Cambridge, and I'm going to talk today about my project, which uses a Google AIY Vision Kit with Spotify to create a mood influence playlist. Yes. So I thought I'd start off by giving a bit of an overview and then going a bit deeper into the types of data employed. So this project was done as part of a Mauser Electromaker competition called the AIY Vision Challenge. And the aim was to use either the Google AIY Vision Kit, which is at the top, or the voice kit to detect a user's emotion and then sort of react, do something to improve that mood. And I chose to use the Vision Kit, in particular the joy detection model. And what this does is it's continuously monitoring someone's face, and it gives them a score from 0 to 1 on how much joy it detects. So 0 would be very, very sad, and 1 would be really, really happy. So something I've always found boosts my mood is music. But what I don't like is when my music doesn't actually match my mood and I have to search through to find the right song to play. And so this project is designed to sort of automate that a little bit. So what it does is it firstly monitors the user's emotion. It then sends that over from the Vision Kit to a separate Pi. And then it picks a song from a data frame based on the different types of audio features in the song. The setup uses a Vision Kit, so the Google AIY Vision Kit, a Raspberry Pi, and a unicorn hat 16 by 16 LED matrix for the visuals. So this is just a bit of an example of a bit of an overview of how this looks. So one of the issues I had was how to get the data from the Vision Kit over to the Pi, and so I ended up using MQTT. So it would constantly be looking at the joy, and it'd take a sort of rolling average, and it would publish that. Then every 10 seconds, the Pi would look at the value. So it kind of continuously monitors, so you're always getting the latest emotion. So on the left, you can see what's inputted by the shell. So it's just saying published. And on the right, you can sort of see what would be received. So you can see all these different values. So you'd see that at the top, 0.027, so quite low, and then it gets a bit higher. So that's sort of what would be received. And by doing a rolling average, it smooths it out a bit, so you're reducing those fluctuations. So this is a bit of an example of the program adding a new song on Spotify. It's a screen recording from my phone. So you see that as the song draws to a close, a new song will be added. Seconds from the end, the program automatically generates that next song. And it uses the latest joy values received to calculate it. And for every song, a new playlist is created. So at the end, you can always look back and see what songs were played. And then finally, the program can be stopped by pressing the button on top of the AIY kit. So now I'd like to move on to talk a little bit about the data I used in my project. Spotify actually has a site. It's called Spotify for Developers, and it details all the different types of data you can get from their API. So you can get information about artists and about albums. So you can see how popular they are, what sort of genres they are. And there's a really important section I used called Get Audio Features. And if you pass in a track, it will tell you all these different values. So you can see we've got valence, we've got tempo, and even further down, it's not in the screen capture, but it gives you about key and mode. Oh no, here they are, key and mode. So all sorts of useful data from that. And this ultimately is what it will filter songs with. So that's what my program used. Also, so this is all about building up the data frame of songs. So this is a large collection of songs the program thinks the user will like. And under personalization on Spotify for Developers website, you can get a user's top played tracks and albums and artists. So the data frame is made from the user's top tracks, the user's top artists' top tracks, similar artists' top tracks, and from the user's favorite genre, the top tracks in that genre. So it goes quite far, spread out to gather all these songs that it thinks the user might like, even songs the user hasn't played before, but there's a recommender system, which is an additional feature, and you can pass in seed artists and seed genres, and it will return back a list of songs it thinks the user might like. So this data frame is made up of all these different tracks. And this is shows what this data frame looks like in Excel. So you can see we've just got the ID, which you use to look at different features about the song, track, artist, and all the different audio features. So there was quite a bit of data employed in this. Here we go. There was also a bit of an experimental part to my project. And what I wanted to do is I wanted to see if I could build a classifier model using the Spotify audio features data to sort it into high energy or low energy based on features like tempo or mode. And I think the biggest issue I came across was there was a bit of a lack of data, which sounds strange, as the data by
Sorry, Lowena, you broke up a bit there.
Continue.
Yeah, we can hear you again, but we missed about 30 seconds or so, I think.
Okay, so
Maybe start the slide again.
Okay, I'll start slide again. So, so I was trying to build a classifier model which classified songs as either high energy or low energy based on their audio features. And the biggest issue I came across was a sort of a lack of data, so a lack of labeled data sets. So what I had to turn to was searching up playlists which had been tagged as used by users as high energy or as low energy. And the issue came from different people have different standards about what they class as high energy. And so there was a bit of the data I was building it from wasn't amazing. So when I managed to create a model, the accuracy wasn't as high as I would have liked, which is why, like I said, it's an experimental feature and it can be quite easily removed from the program. But I'm confident with more data passed in and better data, the model's accuracy can be improved. So I think that'd be something interesting to look at in the future. Thank you. If there's any questions to do with the program or anything you'd like to know about it, you can ask them now, or you could message me on Twitter or email.
There's a question in the chat.
Mm-hmm.
Oh, DJ, do you want to ask that question?
I was wondering, do you measure the joy of a playing track and feed that back into the model?
So what I do is all of the information about these songs is done sort of before the player even begins. So I have starting scripts, which what they do is they'll generate. So I've got one script which another script which will classify the songs.
Mm-hmm.
I guess what DJ is asking is, could you take that and feed it back into Spotify to improve their data?
I think that would be interesting.
To enjoy while the song is playing.
Or at least do it with the private model so that you get a better precision of what brings you joy Because if you're sitting there and the classifier's gone, hey, this will make you happy, and you're not looking happy.
Yeah, that I don't know. I think that's actually really good. I'd like to implement something like that. So it's constantly monitoring and saying, how has the person reacted to putting on this song? Oh, I see what you mean. Yes, that would be good.
You'd also fingerprint it over the length of the track. Because I know there's some music I listen to, and it goes into the outro, and the outro kind of makes you sad. You don't want to be measuring that at the end. So you want to kind of average fingerprint and go, yeah, this song up to about there, and then we'll go to something else.
Changes at certain parts in the song as well. Yes, that'd be good.
This seems like a really powerful interface they provide to Spotify. It must be. I wonder, do you know what else? Where else it's been used? There must be quite a few different applications people have come up with.
Oh, my internet's not too good.
Did you get that question? Yeah.
So is there any other questions? Sorry, my internet's not too good around college. Everyone's trying to get, yeah.
Yeah, sorry. So I had a question. So are you aware of what other applications have used that same API? Because it seems like really useful.
Yeah, it is. Actually, on the Spotify for Developers page, you can look at other projects people have made are using this data. They're quite interesting to have a look through. I believe there was a website. There's a couple of websites actually. And you can see all the different ways people have implemented it, because my project only used a certain couple of features. So it used the get audio features, like I mentioned. It also used a player. So what that does is it allows you to control Spotify on a phone or a laptop using the script, so from the Pi. So what that allowed me to do is it allowed me to play music from my laptop, which is quite convenient. But yeah, there's a whole host of different features which I couldn't implement in my project for fear of making it a bit complicated.
Yeah.
But I'd love to do another project which went a bit further around and used a couple of things I never got around to using.
And the Google AI itself, that's quite easy to use. Is it up and running quite quickly? Or did it have a learning curve that took quite a bit of time messing around with it?
Yeah, there was a couple of issues with the setup, but it's mostly okay. One of the things I found with the AIY kit is if you try and update it, so it runs using its own version, its own like modified version of Raspbian. So if you try and install something like Pandas and you try and update it, I found you can't do the demos. It won't do them. It sort of breaks it, if that makes sense, which is actually why I had to employ the Pi.
Oh, okay.
You then use Pandas on, because I couldn't put Pandas on the AIY Vision kit without that stopping the camera. But if anyone has a solution to that.
Yeah, I guess, does anyone have a solution to that? I don't know. That seems pretty good though. That's very, it's a simple way, is it? Because Pis are cheap, you can do that sort of thing. Using, well, let's get another Pi.
Yeah, I was like, the easiest way around it is just to add another Pi to it. But made the setup a bit bigger. Yeah.
So I don't know if anyone has any other experience with that. Is there any other workarounds anyone knows? Or any?
You can try using containers, but that's another whole different ball game, unfortunately.
I could look into it.
Yeah, it's a way of compartmentalizing parts of the operating system and the environment, and still allowing it to communicate. But again, it's another environment to learn. But you could have it all on a Pi. Pi supports that.
Yes, I'd like to see if I can get it on one thing, because it's a bit of a hassle having them both set up. I can minimize it because they are quite close, but it'd be nice to have it more contained as a project.
You wouldn't have to use MQTT then either, would you?
Yes, the MQTT didn't end up being that much of an issue. It's very reliable and stuff was received very quickly.
It's very easy to use, but again,
yeah,
it's another element of the thing. But you're introducing containers, so yes, you're trading one for another.
You're swapping problems.
Yeah.
So Carl, I think you have a question. Did you want to ask that? Carl? Carl asked in the
Talking
chat.
to me or a different Carl?
No, you, Carl.
I didn't have a question, no. I was just
Oh,
absorbing
sorry.
this. It's so interesting.
Someone asked. Someone asked how you, or maybe it was Pete. So Pete asked, the incoming data quite noisy. What did you implement to sort any sort of filter for smoothing the input? I guess you just did a running average, didn't you?
Yeah, I did a kind of rolling average. So I would, yeah, I wouldn't, I think what I could do is not transmit as often and take take more data values to calculate the average. That might smooth it out a bit. I could probably do that because I wouldn't be expecting a motion to change in 10 seconds, which is the transmission rate. I wouldn't expect.
Yeah, I do that on my home automation with all the temperature and humidity. Take 12 readings, chop out the 3 at each end, and then average the rest. Because otherwise, I found I got spikes all over the place.
Yes, the spikes is an issue. I think in the demonstration I showed, it was from a demonstration I gave earlier in the week to one of the SX2 Mets, and I was very obviously trying to smile really big and then like make myself really sad to demonstrate how the values change. So it's not usually that bad with fluctuations, but it could be smoother.
Can I tell the difference between a fake smile and a genuine smile? Can I tell the difference between a genuine smile and a fake smile?
Oh, probably not. I know when I was testing it, nothing was working, but I still had to get the happy value. So I would just plaster a very big smile and hope it detected it right. It seems to take a lot of face value, if you'll excuse the pun.
Does it handle like extreme issues like having your tongue out for disgust or?
I'd have to test it a bit more.
Thumbs down.
It seems pretty accurate. I think the biggest issue it has is I will have a very small smile, or I won't be frowning. I'll just have a very blank face, and it will register that as sad. I think that might be an issue because generally when you're listening to music, you're not actively smiling to show you enjoy it, but you can't be very subtle with it. That's probably one of the main flaws I would pick out with the model.
Yeah, I guess it's one of those things that improve over time, I guess.
It's like sentiment analysis on text. It's kind of erratic. Sometimes you'll sit there and go, yeah, it's spot on, and then, no, wait.
Yes. Precisely.
Yeah, I was going to ask a kind of related question, which is how happy or how satisfied were you with its music choices? Was it good at getting the right choice or a bit hit and miss?
It depends. I found it was quite good with the sadder ones than it was with the happy ones. I think that's probably because, as I was saying earlier, when I was trying to get data for high energy and low energy songs, it was quite difficult to get that. So yeah, it would work better with sad than happy. So it depends what kind of mood you're in when you want to use it.
Just wonder if it's a good thing that if someone's sad, play sad music.
Yes, if you break it down, it is roughly that, but it's
cool.
A bit of a more fun way.
Any other questions, anyone?
I was just wondering if you put the code up online or something like that. It's just interesting.
Yeah, I do have it on GitHub.
You don't have to tell us now. You can post it on via Richard or.
Yeah, I can get a link there. So that's a link there, but.
Cool.
Oh, I can send the link after if you'd like.
Yeah, cool.
I was going to make a couple more adjustments to it because there's a couple of things I'd like to tidy up, but that's just the code that I sent.
I know the difference between ready for demo and ready for release is two very different.
It's not the nicest looking in the world, but it does what I'd like it to do.
Cool. Awesome project, awesome talk.
Yeah, very nice project. I really like that. Very good. Thanks very much.